Good afternoon, everyone. We'll be starting the webinar in another 2 to 3 minutes. Good noon, everyone. On behalf of School of Agricultural Sciences and Engineering, IFTM University Muradabad, myself Richa Khanna welcomes you all in today's webinar on the occasion of Earth Day 2021. We are glad that today Dr. A.S. Nain, who is Professor, Director Research and NABARD Chair at GB Pant University of Agriculture and Technology, is with us. Dr. Nain has obtained his PhD degree in the field of remote sensing and GIS from Space Application Center ISRO. Dr. Nain is working on a number of research projects and he has numerous publications in his credits. Sir has been awarded with National Fellowship by ISRO and many awards such as Young Scientist Award, Faculty Excellence Award, BB Singh Outstanding Scientist Award, and many awards in seminars and symposium. He has been associated with several national and international projects at Germany, USA, UK, Poland, Switzerland, etc. And he has held several prestigious positions like Vice President of Association of Agrometeorologists. Sir is also serving as a coordinator of ISRO's outreach program of remote sensing, GIS, and GPS. He is acting as a group leader of Geoinformatics Consortium, program director of Center of Excellence of Remote Sensing and GIS in Agriculture, which is being supported by USEC, Uttarakhand, and many more. He was a visiting scientist at Lisbon Center for Agricultural Landscape Research at Germany. I am one of his proud students, and today we are extremely fortunate that Sir is with us. Now, it is my humble request to Dr. Viren Singh, Director of School of Agriculture Sciences and Engineering, to welcome Dr. Nain and brief about today's webinar. Sir, over to you.
Thank you, ma'am. Good afternoon, everyone. Honorable Chancellor, Sir, Sri Rajiv Kotiwal ji, Pro Chancellor, Sir, Mr. Abhinav Kotiwal ji, Vice Chancellor, Sir, Professor Mahendra Prasad Pandey ji, Registrar, Sir, Professor Sanjeev Agrawal, Pro Vice Chancellor, Professor Rahul Kumar Mishra ji, Director Training and Placement, Mr. K.K. Banshal, Directors of different schools, Director IQAC, faculty members, and dear participants. Myself, Dr. Viren Singh, extend a very warm welcome to Dr. Ajeet Singh Nain as the main speaker of today's webinar. Sir, really it is a matter of pride for all of us to have you today. Dr. Nain is a very renowned personality in the field of agrometeorology. Dear participants, today we are celebrating Earth Day, and it is our moral responsibility to save our Earth from ill effects of climate change. Climate change is mainly responsible for a number of natural climatics taking place around us, and in order to safeguard our Earth, first we have to fight with climate change. I am sure that this webinar will be beneficial for all of us. Professor Nain, you are requested to start with the webinar. Professor Nain, sir, over to you.
Thank you, Dr. Viren Singh, sir, and all the respected dignitaries sitting out there and have joined this important day. The very outset, I would like to compliment and congratulate the entire university IFTM for selecting this occasion to have a webinar on such an important topic. When we know that Earth is burning, it is important that we should restore the Earth. And this is the right occasion that while we will celebrate the Earth Day, we will also resolve in ourselves that we will not harm the environmental conditions, the physical conditions of the Earth. So that is why you all have chosen this day very appropriately, and I would like to compliment you all. My dear students, today I would be speaking on climate change, how the climate change is happening, what basically climate change is, and how it is impacting agriculture. What option we have to resolve the issue of climate change, may it be the mitigation options or the adaptation options. Those we would be discussing. Let me share my presentation for clarity. Is the screen visible to all?
No, sir.
Is it visible now?
No, sir.
No?
No.
No, sir.
No, sir.
No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. No, s
Now I think it is visible.
Yes, sir, it is visible.
Hello.
Yes, sir, it is
Okay.
visible now.
Okay. Thank you very much. So the theme for this year, no, 2021, for this Earth Day is restoring our Earth. Restoring, you all know that what changes no we had done in the environmental system of the Earth that need to be restored. That means we will have to reset our environment to the older position. You all know that no industrialization started somewhere 1750, and since there's many things have happened which have no changed the environmental system of the earth, so those need to be restored. I mean, the climatic conditions of the earth need to be restored at the level where it was before the industrialization started. If you consider this Earth Day was first celebrated somewhere in 1970, and you would be happy to know that the young population of the United States of the America at that time, they took this this whole movement into their hand, and they mobilized basically the entire population. And at that time almost 10 million pupils came out from their homes, from their offices, and they tried to celebrate this Earth Day. So this was the first time when the Earth Day was celebrated in United States of the America. And down the line 20 years, then it went global, and then more than 140 countries, they accepted this Earth Day, and since then it has become the international event. If you see, there is exclusive website that is known as earthday.org, and that specifically put all the contents related to the Earth Day. If you will Google that website, then you will come to know how it has changed, how the celebration of Earth Day from 1970 to present, how it has changed. You know that now internet is a very important tool, and without internet, no, there cannot be the exchange of the idea, exchange of the information. And now this Earth Day is mostly relying on the connectivity, connecting the pupils, making the pupil aware with the Earth Day, what losses we have incurred to the environmental system, how environment is affecting the life of common man. So all that kind of things you will find on that website. If you see the earth evolution, sorry, the spelling is mistake there, it is evolution. If you see the earth evolved somewhere 5 billion years ago, and we all know that earlier our earth was part of the sun, and it was also like a hot sphere, gas of the gases, and slowly and gradually it cooled down, and the cloud formation took place. The water in form of rain that accumulated over the earth, and from there then there was the origin of life. If you see, the first life sign occurred somewhere 4 billion years ago in form of prokaryotes, which was basically the cell without nuclei. And later on, the photosynthesis started. And when the photosynthesis started, you all know that out of this photosynthesis, there would be release of the oxygen, because in the process of photosynthesis, the cells or the multicells, they will use CO2 and will convert this CO2 into the oxygen. So that is how the oxygen came on the earth in the environment of the earth. And later on, eukaryotes, which were having basically the nuclei, those developed somewhere 2 billion years ago. And that is how gradually then bacteria, protozoa, sponges, fungi, corals, etc., etc. And finally, then you can see the fish and mammals, birds, these all came on the earth. And finally, the Homo sapiens, which we consider our ancestors, those came on the earth. And that is how the present era of the life that was evolved during these 5 billion years. Now, coming to the climate change, and we know that climate is changing, and it is changing at a very alarming rate. There is hue and cry related to the climate change. Everybody is talking about, and not only the talking about, but almost everybody is witnessing. Everybody has started experiencing the heat of climate change. You know that whenever you will discuss with your parents or grandparents, you will get to know that earlier there would have been the continuous rainfalls, all the ponds of the villages, those were filled with the water. But nowadays, the rainfall is kind of a distinct dream. The very few rainfall event will take place. Very less amount of rainfall would be there. And that is how the ponds, those were basically full of water during earlier times. Now they remain empty. So this is one form of climate change. The another form of climate change is a sudden increase of temperature, sudden decrease of temperature. See, climate change is not always associated with increasing temperature, but it is associated with both extremes. It could be the positive increase in the temperature. It could also be the negative temperature. Negative means there could be no sudden drops in the temperature. So what I mean to say is that there would be extreme climatic conditions whenever there would be the climate change. We mostly relate climate change with the global warming. I will mention that global warming is one form of climate change, but global warming is not the entire climate change. So we need to understand basic difference between the global warming and the climate change. The critical questions which we would be taking up today for discussion, those are different forms of climate change. What these are: greenhouse gas effect. What is the relationship between greenhouse gas and climate? The trends of climate change, climatic projections, how climate affect the growth and development of plants. Does agriculture hold any promise in mitigation of greenhouse gases emission? And lastly, how agriculture helps to cope up with impact of climate change. So these would be the critical questions where we would be discussing today. So starting with the first question, what is climate change? Climate change, as I mentioned, that increasing temperature could be one form of climate change, but that is not the only form of climate change. There could be multiple other factors. And on the screen, you can see that when the temperature will increase, so that you can consider as climate change. But as I mentioned, that not only that, but sometime it will happen that the mean of temperature is same or even less than what you are witnessing. But then the extreme condition, that means the hotter time is becoming more hotter, and colder time is becoming more colder. So that is also another form of climate change. And in that case, basically the variance will increase, but the average condition either will not change, or maybe if it will change, it will show you some kind of positive indication, but doesn't mean that it is not form of climate change. And sometime you will see both, that the temperature will also increase and also the variance will increase. And this is what you are witnessing at this point of time. Not only the temperature that is increasing, but also the variability is increasing. Variability means the extreme conditions both sides. Colder days are becoming more colder and hotter days are becoming more hotter. But in case of hotter days, those are no even much hotter than the frequency of the colder days. Now coming to the second question, what is greenhouse effect? See, greenhouse, if you would have seen sometime, greenhouse is basically a glass house where the plants are grown, and because it is the glass house, so it allows radiation to come in, but it will not allow the radiation to go out. The question in your mind will come that when it is allowing the radiation to come in, why it is not allowing the radiation to go out? The reason is when the temperature will come inside the glass house. For example, this you can see this is the sun. This radiation when will come from the sun, it would be mostly in the shorter wavelength. And when it will come inside, there would be plants, there would be soil, there would be different other materials. So those will absorb this short wave radiation, and then they will emit their own radiation. And because their temperature is quite smaller as compared to the sun temperature is considered as 6,000 Kelvin. And the temperature of all the objects within the glass house would be like 25 degrees centigrade or 30 degree or 35 degrees centigrade or 40 degree for higher side if you are taking. So even at that temperature, the object will emit radiation over to the long waves, and these long waves cannot be move out from these
Excuse me,
glasses.
sir.
Yes.
The screen is not visible.
Screen is not visible.
Yes, sir.
What is visible then?
Your logo.
Screen is visible. आप देखिए screen is visible, sir.
अच्छा, कुछ केसेस में प्रोबेबली नहीं हो रहा होगा जहां नेट की कनेक्टिविटी की प्रॉब्लम होगी, मेरे को लगता है.
Right, sir. Right, sir. Okay.
जी सर.
Sir, please
So
continue.
what should I do?
No, sir. Please continue, sir.
Continue. Okay.
Yeah, sir.
Achha, another thing I should ask it before starting my this discussion. Student, how good they are in English, or should I just switch over this to Hindi?
No, sir. Please continue in the English as well.
Okay, that's fine.
English.
Okay, that's fine. That's fine. Thank you very much. So coming back to the discussion that this glass is having this peculiar property that it allows the shorter wavelength to pass through, but it doesn't allow the longer wavelength to pass through. And that is why, because it will not allow the longer wavelength to go out, that is why the temperature of this glass house will rise. And this is known the peculiar phenomena of any glass house, that the temperature of glass house will always be higher than the open field. And same thing will happen in atmosphere when there would be few gases, greenhouse gases. These greenhouse gases, these will act in the similar manner as this glass does. These gases like CO2, CH4, nitrous oxide, etc., these will allow shorter wavelength from the sun that will come at the Earth's surface. And when the Earth's surface will absorb these shorter wavelength, then on the basis of the temperature of the Earth and its object, then it will emit the radiation in longer wavelength, and the longer wavelengths are checked by these gases. And that is why, because this phenomena is just similar to the phenomena of glass house, this effect is known as greenhouse effect, and these gases are known as greenhouse gases. Now, coming to this, how this radiation is coming and how this radiation is going out. You can see in this case that sun is contributing all the radiation that is coming on the Earth's surface. And when it will enter into the atmosphere, some part of radiation would be reflected by the cloud that will directly go into the space. Then a majority of the radiation will come on the Earth's surface, and Earth's surface will absorb this majority of the radiation. Only small radiation would be reflected. This reflected radiation, because reflection is different than the emission, we should always remember. Reflection would be in the same wavelength, while emission would be that the Earth will absorb radiation and will emit radiation on the basis of its own temperature. So when the radiation would be reflected, it will again go through atmosphere into the space. Why? However, the radiation which is being emitted by the Earth's surface, that is being emitted in the longer wavelength, that would be checked by atmosphere, and atmosphere, because it is having carbon dioxide, it is having CH4, it is having nitrous oxide, etc., etc. So that is why the temperature of the atmosphere will rise. And the temperature of atmosphere will always rise from the bottom. You would have seen by now that the radiation is coming at Earth's surface, and from Earth's surface it is being emitted, which will go into the air, and air which is close to the Earth will be the first to get this radiation or this heat. And that is why we always consider that the atmosphere is always heated from the bottom side. And as I mentioned, that this heating will take place because of these greenhouse gases. Now, if the concentration of greenhouse gases that is not varying, that is constant, then there is no point of worry, because that is also needed. Assuming that there is no greenhouse gas in the atmosphere, so atmosphere would have been very, very cool. So for survival of the life on the Earth's surface, greenhouse gases are important, but they are important up to certain limit. If the greenhouse gases will increase beyond that limit, then there would be negative impact. There would then be increasing in the temperature, and when the temperature will increase, then it will bring impacts on almost all climatic variable. See, according to a projection, it has been analyzed that if temperature, the average temperature I am talking about, average temperature of Earth, if it will rise more than 2 degrees centigrade, then there would be so many sudden climatic changes, uncontrolled climatic changes, that then the life on the Earth would be threatened. CO2 is really increasing or not? So there have been instrumental observations, and instrumental observations not in a region where no humanity is there, because if you will take observation in any city, so the observation will always be affected by the city climate. So there are 2 observatories, one which is located at Mauna Loa. It is very remote place where from this place to thousands of the kilometer, no human life is found. And then there is another observatory that is located at South Pole. And both of these observatories are indicating that carbon dioxide is continuously increasing. And it has earlier, when we were a student, we were studying in the textbook that the carbon dioxide is 0.03% in the atmosphere. But now it has increased to 412 part per million in atmosphere. So that shows that carbon dioxide is really increasing in the atmosphere. And this red line you can see. And red line, when you will see, it is having kind of seesaw pattern or saw pattern. Saw means जो लकड़ी काटने की जो आरी होती है उसकी तरह का आपने देखा होगा. Saw pattern, there would be no like these teeth like structures, and these up and downs of this green season. See, whenever there would be winter, during winter time, there would be less vegetation on the earth. And when there is less vegetation, that vegetation used to absorb carbon dioxide from atmosphere. So during winter time, this amount of CO2 in atmosphere will increase. But after winter, when there would be spring and there would be greenery on the earth, so this greenery, when the greenery will come, it would be the most active stage of the photosynthesis. And when there would be this photosynthesis, so there would be absorption of CO2. So immediately after winter time, when the time will enter into the spring, so the CO2 will decrease little bit. But then the long-term trend is clearly indicating that carbon dioxide is continuously increasing. And this carbon dioxide increase is also evident from the pH of the ocean. You can see that the pH of the ocean is decreasing, and that is also indication of carbon dioxide increase in atmosphere. You can also see that the trends of the other greenhouse gases like nitrous oxide, that is increasing, methane concentration, then sulfate aerosols, those are also increasing in atmosphere. And these are the instrumental records. Though the paleoclimate has also been established by using this air trapped in the ice, and that paleoclimate analysis is also suggesting that the concentration of these greenhouse gases that is continuously increasing. But that is kind of a post analysis and certain assumptions. But records are clearly showing that greenhouse gases are increasing. Now, if you see these greenhouse gases, and we had so far discussed that carbon dioxide has been the important one. And if you consider the global warming potential of CO2 as 1, so methane is 21 times more powerful than the CO2. Nitrous oxide, which is coming from fertilizer industry, that is 310 times more effective than the CO2. And then CFC, HCFC, perfluoroethane, sulfur hexafluoride, these are thousands times more effective than the CO2. But then their concentration is not that much as of CO2. CO2 concentration is increasing much more than any other these gases which we just discussed. If you talk about the radiative forcing, now this is the new term which need to be discussed. Radiative forcing is that how much additional energy these gases are bringing into the Earth climatic system. See, we know that sun is bringing lots of energy into the Earth's climatic system, but in addition to the Earth, these gases which are absorbing these long wave radiation that is going from the Earth, when they will absorb these long waves, these are ultimately energy. So when these will absorb this energy, they will also radiate that energy. So this radiative forcing is that forcing that carbon dioxide, since industrialization, it has added almost 1.68 watt energy per meter square, while methane has added almost 0.97 watt, and nitrous oxide has added 0.17. Then CFC12 has also added 0.17 watt. So these greenhouse gases are adding these extra energy into the atmospheric system, and that is why the temperature is continuously increasing, and that is cause of concern. This is again the comparative figure of all these gases, how these are affecting this radiative forcing, and what is the range of this radiative forcing, and what is the cumulative effect. If you see by 1980, by 1950, if you consider, the total radiative forcing was 0.57 watt per meter square. In 1980, it has increased to 1.25 watt per meter square. So in 30 years, you can see it increased almost 0.7 watt. And in last 30 years, you can see from 1.25 to 2.29. That means 1.04 radiative forcing has increased during past 30 years. And if you will further analyze, because we are now running into 2021, so you will see that it would have further increased. Maybe now this radiative forcing would have reached somewhere 2.40, though the current figures are not available. When the new report, IPCC report, would be released, those latest estimation would be provided. But what I mean to say is that this radiative forcing is increasing at much accelerated pace in the current past, what it used to be during earlier days, and that is the cause of concern. Now, how this temperature and the different climatic factors, these are intermingled with one another. If you talk about the greenhouse gases, and if greenhouse, we have discussed that greenhouse gases are increasing in the atmosphere. We have established that through instrumental records and even paleoclimatic analysis. The greenhouse gas is increasing in the atmosphere, and when it will increase, the temperature will also increase. And when the temperature will increase, so evapotranspiration is basically the joint process of evaporation and the transpiration. Evaporation, when the water would be lost from the physical surface, and transpiration when the water would be lost from the plants through stomata. So this evapotranspiration will increase, and when the evapotranspiration will increase, the specific humidity, that will definitely increase, but relative humidity will depend as to, because it is relative humidity, so as to whether the temperature has increased more or the water has increased more, so the relative humidity will depend on that. But the cumulative effect of this higher specific humidity would be increasing precipitation. Now you will ask, the question will come in your mind that I was saying that the precipitation is decreasing. We are not witnessing, we are not seeing that much water in the ponds which we used to be in the past. And this in this case, I am saying that precipitation is increasing. It is true that precipitation will increase, but then the number of rainy days, those will definitely decrease. And when the number of rainy days will decrease, that also means that there would be downpour. Downpour means there would be no sudden rainfall, too much water will fall, then it will run off, and the soil or the land will not be able to absorb it. And that is why the water which has fallen in terms of this downpour, that is not utilized by the plants, by the soil. And that is why it will create the kind of this soil dryness condition. And it will also cause soil losses, because whenever there would be high intense rainfall, so their power, when this water will move, especially on the slopy land, their power would be much more. And that is why the soil, which is very precious natural resource, that is lost. Soil dryness will increase, and that will finally lead to decreasing crop productivity. So that would be the overall impact of greenhouse gas and climate. These are the observed changes in temperature, and these are also suggesting the same thing, that temperature is continuously rising ever since this industrialization process started. But the cause of concern is that in the recent past, it has increased at a much accelerated rate than any other time. These are basically the surface temperature which have been observed on the Earth's surface during almost last 1 century. And you can see that almost at all places the temperature has increased, except at 1 or 2 places where the temperature has decreased. But more increase in temperature is being experienced in more colder regions, the temperate regions. The reason responsible for this is, though there would be maximum insolation would be in the tropical region. You know that the sun rays will come directly in the tropical region, and that is why the more energy is available in the tropical region. But because tropical regions are already having too much of the energy, this energy is also then transferred to the regions where the temperature at this time is less. And that is why you will experience that this temperate regions, or the regions close to the polar regions, they will have much higher temperature in terms of increase in temperature, not the absolute I am talking about, but more increment in temperature rather than the tropical region. But this increase in temperature in temperate region is not that much detrimental. The reason being is this is causing increased growing period in that region. Otherwise, this region will be mostly snowbound region, and because the temperature has increased in this region, so that is why this growing season has increased. So it has brought positive impact in that region, but it will always bring negative impact in the tropical region if temperature in the tropical region is increasing. The reason is that tropical region is already quite hot, and there is water deficiency that is being felt. And if further temperature will increase, the demand of water will further increase, and that is why there would be the loss of productivity in the tropical region. So these tropical regions, as far as climate change is concerned, these are the hot belts. These are the regions where we will immediately feel the impact, the negative impact of climate change on the human being and on the agriculture system. These are the trends again, but these trends are belonging to our own country, India. And you can see there are three graphs, the top one, middle and bottom. Top one is showing you the temperature trends of mean temperature. Mean means the mean average of maximum and minimum. And you can see that temperature is continuously increasing. And these are instrumental record. But again, the cause of concern is that the temperature during recent past, those are increasing at much accelerated rate, whether it is maximum temperature or minimum temperature. So everywhere you are seeing the similar kind of trends. These figures are showing the precipitation over land, and you can see that precipitation from 1901 to 2010 and 1951 to 2010. And this figure shows that in most of cases the precipitation is increasing, but then there are certain other areas where precipitation is increasing, and especially in this tropical region you can see that because of climatic changes in climatic circulations, even there would be no impact on the precipitation. And this precipitation which is changing, it has been felt more during 1951 to 2010. And if you look at the precipitation trend over India, that is showing the negative pattern, you can see. And this negative pattern, again, you can see that during recent past, it is more visible than the earlier it used to be. Then if you see the northern hemisphere spring snow cover, that is also showing the decreasing pattern, whether it is a spring snow cover or the summer sea ice extent, both are showing the negative trend. That means the ice in the polar region, that is decreasing. It is decreasing in the volume, that is decreasing in the area, that is decreasing in the weight. So at all parameters, it is showing the decreasing trend. And when the ice will decrease, so that means ice will melt into the water, and when the ice will melt into the water, so the water level will increase. And when the water level will increase, the regions which are just close to the sea, those will see this inundated water. And it is just projection, but this projection shows that if the water level will increase by 1.5 meter, then the population which would be affected would be almost 15% of the population. And the total area which would be affected would be like 22,000 square kilometer. That analysis is merely belonging to our neighboring state, Bangladesh. But I admit that these are very exaggerated analyses, because the water rise by 1.5 meter is not possible in the near future. But these are just just the analysis, just the projection. If it will happen, then this is going to happen. But it shows, it it basically alerts us that if we will not change ourselves, then we will have to see these repercussions. Now coming to the local climatic trends, and because I am from Pantnagar, so we also try to analyze the weather data of Pantnagar, and that is also showing some kind of changes. But these changes are not the same changes as at the national level. You can see that the average temperature at Pantnagar is decreasing, it is not increasing. While average maximum temperature is decreasing, and you can see that average minimum temperature is increasing. This is peculiar trend at the Pantnagar, and this trend, why we are noticing, let me explain. See, in Pantnagar, Pantnagar used to be earlier a very distinct place, just close to the Himalayan region, full of greenery, etc., etc. And when this new state was carved out, Uttarakhand, so industrial state was established just close to the Pantnagar. And because of this industrialization, now because of this the pollution which they thrown into the atmosphere, because of the water which we drawn, because of the increased evaporation and transpiration as well, so the water in the atmosphere that increased, and when the water in the atmosphere increased, it then converted into number one, cloud during summers, and number two, fog during winters. And because of that, then this maximum temperature decrease. See, you know that if there is cloud during daytime, so this radiation which is coming from the sun, that would be checked. And when it would be checked, it will not reach on the ground, earth surface, and that is why the temperature will appear as if it is decreasing during day. So maximum temperature is always attained during day, and that is why this maximum temperature is showing you the negative trend. While this minimum temperature, that will always occur during night, or you can say early morning. Before sunset, there would be minimum temperature. But minimum temperature, you can relate, it would be the temperature of the night. And the same cloud cover or same fog condition, if it is persisting during night as well, the radiation which is the long wave radiation I am talking about, the radiation which is liberated or which is released by the earth, that is trapped, that is blocked by the cloud and fog. That is why the temperature during night will increase. But when you will see this cumulative effect, that means if you will just put this average temperature, so average temperature will not show you any trend, because one is showing positive, another is showing negative. So positive and negative, those would be nullified, and that is why the average temperature will not show you any trend. But these two temperature, when you will put differently, then these will show you the alarming trend. Rainfall at Pantnagar is showing increasing tendency, that is visible, but bright sunshine hour is again related with the cloud cover, that is showing decreasing trend. Now coming to the projections, we have discussed quite a lot about the past trend, but what would be the future? See, future will depend how we will behave. See, there are these 4 different projections. The RCP, that is representative concentration pathway 8.5. These 8.5, these digits, 6, 4.5, 2.6, all these are representative concentration pathway. And these digits are basically showing you the radiative forcing. See, if no policy which will control this pollution or greenhouse gases is put into a place, then no, this greenhouse gas emission will remain uncontrolled, and we would be reaching at 8.5 radiative forcing. If some policies which can be adapted by the international community, if these are put into the place, then the 4.5 radiative forcing would be achieved. And if stringent policies are put into place, then only we will restrict this radiative forcing to 2.6. And I mentioned that it is important that we should limit this the greenhouse gases to the extent that the temperature should not increase beyond 2 degrees centigrade. Further things would be clear from this particular diagram. These are showing all these representative concentration pathway. You can see that if RCP 2.6, when there would be stringent policies of these greenhouse gas emission, then the level of carbon dioxide, we would be maximum level, we would be attaining to 475 ppm, and then it would be decreasing. And it will result almost plus 1 degree centigrade from now. If we will not put these stringent policies and the policies which we are talking about nowadays and all international communities agreeing to, then we will limit this RCP to 4.5, and the carbon dioxide concentration will go up to 630 ppm, and that will result into almost 1.8 degrees centigrade increase in temperature. So this up to even 1.8 degrees centigrade we can tolerate. But if suppose we have not done this, and if suppose we have done this RCP 6, then no, it would be 2.2 degrees centigrade, and 2.2 degrees centigrade is that level which this humidity should not attain. Otherwise, there would be so many drastic changes in the atmosphere that those would be uncontrolled. And if nothing is being done, then RCP 8.5 we will see, and then the temperature will rise by 3.7 degrees centigrade, and then only God knows what will happen, because humanity cannot then tolerate those changes which will happen. These are spatial distributions, how these temperature will change in the next century. I am not going into the much detail. And the temperature, how these will change over our own country. You can see that the temperature, much changes would be seen in the cold region, while less changes would be seen in already hot region. And in case of precipitation, also, though the country as a whole would be benefiting out of this climate change, because precipitation will increase, but this increasing precipitation does not mean that this water would be available for no uses, because it would be drained, and it will also cause soil erosion and no other losses. And at the same time, certain regions we will also see where the precipitation will decrease. Now coming to the climate and plant, and this diagram shows how the plant used to respond to the temperature. On x-axis, you can see the temperature, and on y-axis, the photosynthesis. Initially with increasing temperature, the photosynthesis will increase, and then it will attain the optimum photosynthesis rate, or the maximum photosynthesis rate, and this stage is known as optimum cardinal temperature. And if temperature will further increase, then the photosynthesis will drop drastically. And if suppose the temperature is reaching 50 degrees centigrade, then everything would be stopped. There won't be any photosynthesis. Now it depends on the reason where this climate change is being discussed, whether the region would be benefited out of climate change or the region will experience the negative impact of climate change. See, if you are here somewhere, so that means that if temperature will increase, you will still feel the positive impact. But if suppose the temperature is already in this range, so further increase in the temperature would be detrimental. So it depends. So always know there would be questions from the audience side. See, what will happen if temperature will increase? So you cannot give any umbrella answer to that. It depends as to where we are at this moment, and further increase in the temperature that can be analyzed in the context of the present condition. This temperature responds to the respiration, and with increasing temperature, the respiration will increase. That is basically the negative to the photosynthesis. In photosynthesis, you used to develop the carbohydrate, the food material, while in respiration, you used to utilize that. Those are losses basically. And when the temperature will increase up to 40 degrees, these losses will increase, and then these will drop. And these will drop because then there won't be any photosynthesis. It doesn't mean that the respiration will decrease, but it is basically because when there won't be any photosynthesis at 50 degrees centigrade, so there won't be respiration as well. Now, CO2 response to photosynthesis. It has been through experimentation, it has been learned that the maximum CO2 can be absorbed at 30 degrees centigrade. So this 30 degrees centigrade temperature is considered as ideal for photosynthesis, for growth of the plants. This shows that when the temperature will increase, how the development times would be, development time of the plant would be from sowing to the harvesting. And this time is inversely proportional to the temperature. That means if temperature is increasing, the development time will decrease. And that also means that in the event of increased temperature, your crop will get matured very quickly. And when the crop is maturing quickly, then the quality of produce that will decrease. Also, the amount of the produce that will decrease. Here you can see how temperature is related with the disease outbreak. And you can see that black rust is depending on the temperature regime. And these are basically related with the months of 14 degree centigrade ISO line. And if further temperature will change, so accordingly the pattern of disease outbreak, those will also change. In one study, it was analyzed if CO2 will increase, what will happen to the plant photosynthesis, and if with the CO2 that if temperature is also increasing, what will happen? See, if only CO2 will increase, then definitely photosynthesis will increase. But if CO2 is increasing with the temperature as well, so then this positive impact would be nullified by this increasing temperature. Here you can see the wheat production projections in India. From 2020 it was analyzed because this study was carried out way back, some 15 years back. So at that time 2020 situation was analyzed and 2050 situation was analyzed. And the yield has been projected to decrease, especially in 2050. though in 2020 it is not known that much affected. In some cases, you can also see that the yield will increase. But in 2050, the yield will decrease, definitely, if the climate will keep on changing as it is doing at the moment. Then the recent trends have also been analyzed, and you can see here that these are the recent trend, how the T max of the monthly mean temperature, how it is changing, and especially during winter months. See, these are the winter months, and these are the summer months. The months above this line, those are the summer months, and these are the winter months. And this figure is showing that the temperature of winter month is increasing. And during winter, you all know, because most of you are from the agriculture background, during this time, there would be the wheat crop in the field. And because of this increasing temperature during winter time, the wheat will mature little early. And when it will mature early, the quality will deteriorate and the quantity will decrease. Similarly, the bright sunshine hour, you can see that is decreasing during winter months. And that is also bringing negative impact on photosynthesis and the growth. Rainfall during these months, winter months, you can see it is showing though the decreasing tendency, but during this time the number of rainy days that is increasing. But one important feature that we could witness is that though the rainfall during winter time, entire Rabi season, that is decreasing, but during February, March and April, especially March and April, when the crop would be ready for harvest, then there would be rain. And this rain, terminal rains, which we used to call, when these will happen, these will bring negative impact. For example, during last 2-3 days, you would have witnessed these rainfall activities with winds. So whenever there would be rainfall and associated winds, so there would be lodging, and when there would be lodging, so the harvesting would be difficult. A huge amount of the wheat that is lost, that cannot be recovered. Not only that, but the quality will also deteriorate. So this is what we have experienced here at Pantnagar, and it is being experienced across the country. Now I am going little quickly, considering the time constant. Then the negative impacts of climate change on agriculture. The overall predictability of weather and climate would decrease, making day-to-day and medium-term planning of farm operation more difficult. Rising temperature in the tropics may result into diminishing yield of some crops due to shortening of crop duration and forced maturity. See, always there would be forced maturity. Whenever the temperature during grain filling will increase, so there would be forced maturity. And out of this forced maturity, the grain size will shrink, the quality will decrease, amount will also decrease. So that is why this will cause the negative impact. High night temperature will increase dark respiration, loss of biodiversity from some of the most fragile environment. Winter kill of pest is likely to be reduced at high latitudes. This is another cause of concern, that winter kill is now not being experienced. See, you would have seen during your early days that during winters, almost mosquitoes, all the mosquitoes would be killed because of this winter time, severe winter condition. But nowadays those severe winter conditions are not coming up, and that is why this winter kill of pests that is not being experienced. Then there would be shifting in agroecological conditions, because when the temperature will change, precipitation will change, so there would be shifting in agroecological conditions. The current imbalance of food production between cool and temperature regions and tropical and subtropical region could worsen. See, you all know that all these climate, and because of this temperate climate, and whenever there would be changes in climate, if suppose temperature is increasing, then these regions would be benefited. Why these would be benefited? Because they will have the longer growth period. So in some cases, it will happen that where they are at the moment taking one crop, they will start taking two crops. So these temperate regions which are already doing good, they would be benefited out of this climate change. While the tropical regions which are already under stress, those will experience the heat of this climate change and their productivity will further decrease. So this balance, the food security balance, that would be disturbed when this climate change will further happen. The requirement of annual irrigation will increase, not only because of higher evaporation, because the tree develop more faster during the 12-month period. Heat unit required will be achieved in much lesser time. So this evaporation will increase, transpiration will increase, and that is why this irrigation demand will also increase. There is another factor that during this climate change and because of this chlorofluorocarbon emission, and chlorofluorocarbon used to basically interact with the with the ozone, and because of that the UVB, ultraviolet B, that will increase, and that will bring some kind of very negative impact on the plants. High tropospheric ozone concentration will also have the toxic effect, and it has been learned from analysis that has been conducted at IISR Calicut that if temperature will further rise by 1 degree centigrade, many regions of the deep south which are popular for spice production, those will not continue to be the spice production belt. So this is no kind of negative impact the climate can bring. Production timing will change. This moment that that may change. It will not happen that the Kharif will become Rabi and Rabi will become Kharif, but then there would be changes in like sowing time, then harvesting. These will get changed. The winter regime and chilling duration will reduce in temperate region, and when the chilling duration is decreasing, then it will also bring negative impact on the temperate food, especially the apple. The kind of the quality apple you are getting at the moment, you will not keep on getting in the future if climate will change. The faster maturity and higher temperature induced ripening will make the producer less storage period in the plant. They will overripe. And finally, the pollination will also be affected because of the climate change. Now, we have discussed too much on the negative side. Now we need to act upon to restore our climate back to what we had, what the nature has given to us. And there are a few options which we can exercise, like renewable energy can be increased. We can use especially this solar energy or the wind energy, or maybe any other form of energy which is renewable and which are not causing these hydrocarbons into the atmosphere. We can practice conservation and organic agriculture. Why I am advocating this conservation agriculture? Because whenever you will do conservation agriculture, you will not use much of the tractor, you will not use much of the other implements, You will not use much of the chemical fertilizers. You will not use much of the irrigation. You will not use much of these pesticide and insecticides. And that is why all these activities are contributing towards the carbon emission into the atmosphere. So conservation agriculture will lead to decreased emission of carbon dioxide and other greenhouse gases in the atmosphere. And this is the need of our to restore our climate. Livestock management is one important factor. And you know that more than 30% methane emission that is coming from the animals. And you know that because of this digestion in animals, they used to liberate huge amount of methane. To check this, we need to have the suitable breeds which are perfectly suiting to the given climatic conditions. We also need to have the suitable diet so that they can digest in a manner that the least possible methane is emitted. Paddy management is another important factor as far as agriculture is concerned, because paddy is also contributing lots of methane into the atmosphere. And you have learned that methane is almost 21 times more powerful than the CO2. And our rice fields are emitting too much of CH4, methane, and you can reduce it, but up to 80% you can reduce by adopting suitable practices. And one such practice is off and on irrigation of the paddy field or mid-season drying of the paddy field. These will not decrease the productivity, but it has been experienced that if the fields are managed well, even the productivity will increase. Only the factor would be how you are going to manage the weeds, because the water that is stagnated in paddy field, that is not requirement of the crop, but it is done because of controlling these weeds. So this control or the management of the weed, that is important when you are doing this mid-term drying of the paddy field. Afforestation has been always discussed, and it is being taught at every platform that we should grow more and more plants. We should do the forestation, and when there would be more trees, more forests, so this, at least the carbon dioxide which is being emitted into the atmosphere, that would be absorbed by these trees. Then we have certain options on you can see right hand side. These are the these are no adaptation options. These are not mitigating. Mitigating means you can reduce something. You like CO2 you can reduce, methane you can reduce. But adaptation is when the climate change has happened, so adjust our activities in the changed climatic condition. Because if suppose climate change is happening and we will have to adjust in the given climatic conditions, so then these are the options which we can practice. Breeding options, we can develop the cultivar which will suit to the changed climatic conditions. Under privileged crops like millets. Millets are having no peculiar characteristic that they can sustain with the adverse climatic conditions. So we will have to grow more millets. Diversification of agriculture is need of the hour, because if you will go with this monoculture system, then you will invite more problems. So always diversification should be done in order to avoid the complete failure of the crops. Soil protection is needed because as I mentioned that whenever there would be more rainfall, so soil would be eroded. crop monitoring and management that is done. Whenever there would be climate change, it is likely that there would be more insects and pests. So those should be regularly monitored and should be managed. Rainwater harvesting is very, very important, and it is especially important in context of India. You would have seen during past 2 years that the metro city like Chennai had dried fully, and there was no water left in the soil, in the land. So that situation can come anytime, any reason, because the water which was stored in the earth during these billions of the years, that most of the water which we have drained out, and now almost entire country is running out of groundwater. So this situation, what Chennai and Tamil Nadu faced 2 years back, that would be felt anywhere in the country in the years to come. So we will have to adapt rainwater harvesting technique, efficient use of the water like micro irrigation technique. Micro irrigation technique will not only save water, but they will also decrease this methane emission into the atmosphere. And finally, we will have to do climate smart agriculture. Climate smart agriculture would be the agriculture suiting to the climatic condition so that the maximum productivity is attained without further harming the climatic conditions. So that is climate smart agriculture, and that is again need of the hour. With these words, I am now closing it. And thank you very much for giving me this opportunity to interact with you. Thank you very much. If you do have any question, please ask.
In case there are no questions, sir, thank you so much for this wonderful and knowledge-packed lecture. I really feel short of words to express my thankfulness to you. And this lecture has really forced all of us to think that how we can restore our earth. With these words, I would like to request Dr. Pant, head of our department, to present a formal vote of thanks.
Thank you, ma'am. On behalf of...
Hello, sir.
जी बोलिए.
Sir, I have a question.
Okay, please. Your question.
Sir, can you explain please that how evapotranspiration has an impact on relative humidity, how it is increasing and decreasing? But you told that humidity is increasing, but humidity is increasing or decreasing both. Please explain that point.
I could not understand what you are asking. Your voice is not visible. Can you again do it?
सर आपने बोला था ना इवापोट्रांसपिरेशन के लिए रिलेटिव ह्यूमिडिटी इंक्रीज भी होता है और डिक्रीज भी होता है, बट स्पेसिफिक ह्यूमिडिटी ओनली इंक्रीज होता है, तो रिलेटिव ह्यूमिडिटी डिक्रीज कैसे हो रहा है वो पॉइंट?
हाँ देखिए, मैंने दो चीज बोला कि स्पेसिफिक ह्यूमिडिटी विल ऑलवेज इंक्रीज, बट रिलेटिव ह्यूमिडिटी कैन इंक्रीज और डिक्रीज बोथ. It will depend whether temperature has increased more or whether evapotranspiration has increased more. See, whenever the temperature will increase, the evapotranspiration will also increase. This is one thing that is clear. But evapotranspiration will only happen when the water is available. If there is no water available, only temperature has increased, and the water has not increased in the atmosphere at that rate as the temperature has increased. So because relative humidity is relative to something, something means that is basically temperature dependent term. So when the temperature has increased more, relative humidity will decrease. When the temperature has not increased more, but the evapotranspiration has So in that case, the relative humidity will increase. You got my point?
Yes.
Hello.
Yes, sir. Thank you, sir.
Okay.
On behalf of the School of Agriculture Sciences and Engineering,
Yes, sir, I understood, sir.
Please, on the behalf of the School of Agriculture Sciences and Engineering, I present my sincere thanks to Dr. S. Nain sir for sparing his valuable time with us. Sir, we are extremely grateful to have you with us. I am sure that this lecture was very beneficial for all of us, and it is enlightened all of us towards ill effect of climate change. We all are very much aware about the ill effects of climate change and its impact on our Mother Earth. So it is our duty to save our Earth in order to have a sustainable development. I present my sincere thanks to our administration for organization of such webinar for betterment of our students and agricultural fraternity. I proceed my sincere thanks to Team Agriculture and all staff members for their valuable supports. Last but not least, I am highly thankful to all the participants for their patience listening. I wish you all good luck. I assure you that we will organize such wonderful events or the webinars in future also, so that you will have a better understanding of different aspects of agriculture. Thank you. Jai Jawan, Jai Bharat.
Thank you.
Thank you, everyone, all the participants. We have also organized a quiz competition at 3 p.m. The link to participate in the quiz we have already shared with you, and उसको हम एक बार और share कर देंगे. You all are requested to participate in the quiz competition also. Thank you so much. You all can leave now.